Hello students, welcome to AK Virtual Math. Today we are going to learn about the exponents. So let's see what does mean by exponents and indices. What are the exponents or what are the indices? So actually these two terms, exponents or indices, these two are analogous terms. So means they both are the same terms or they both have the same meaning. So let's see what does mean by exponents. What are the exponents? So see, if we have repeated multiplication of anything, like here we have multiplication of 2, 2 into 2 into 2 like this. These two are multiplying repeatedly. So how do we write this? We write like this, 2, how many times these 2 multiplied? So 3 times. So we write 3 here, this small number above this 2. So this 3 tells that this 2 is multiplied repeatedly 3 times. So in the same way, if we have any other number like 5 into 5 into 5 into 5. So see, this 5 is multiplied how many times? 4 times. So we can just write like this 5, and above 5 we write this small 4 here. So this type of notation, this type of representation of repeated multiplication is called exponents, or sometimes it is called indices also. So if I write any exponents like this, suppose 7 raised to the power 3. So how do we read like this? This is called power. The number which is written here, that is called power, or sometime it is called index as well. So which tells that this 7 is multiplied repeatedly how many times, and this number is called base. So this is base is 7 and power is 3, or index of 7 is 3, and all together this whole thing is called exponents, or this whole thing is called index or indices. So let's see what are the different laws of exponents or indices, how we can do different operations with the exponents, like multiplication of two exponents, how we can do division of two exponents, how we can do. So we'll see here different laws of exponents. I hope you understood what are the exponents. So exponents are the repeated multiplication of anything, whether it is a number or variable. So it may be like this variable also, like if you are multiplying x time x time x time x. So you can see this x is multiplied how many times? 4 times. It is repeatedly multiplied 4 times. 1, 2, 3, 4. So we can write x and raise to the power 4. So means this is power is 4, base is x. So this is power, and now here this is base. In exponents, two things are there, power and base. So now let's see what are the different laws of exponents. Let's see the first law of exponents. If I'll say we have two exponents in multiplication, like first one is 2 raised to the power 3 and multiplied by 2 raised to the power 5. So how we can multiply these two exponents? So let's see. This 2 raised to the power 3 means what? This 2 is multiplied repeatedly 3 times. So we'll write here 2 times 2 times 2. Okay. Now 2 raised to the power 5 means what? It means this 5 is multiplied repeatedly 5 times. So 2 times 2 times 2 times 2 and times 2. So 1, 2, 3, 4, 5 time. Okay. So we can see here this is 1, 2, 3, 4, 5, 6, 7, 8 time. So we can directly write 2 raised to the power 8. It means this 2 is multiplied repeatedly 8 times. So this will become 2 raised to the power 8. If we'll multiply 2 raised to the power 3 into 2 raised to the power 5. So we can directly say that this 2 raised to the power 3 into 2 raised to the power 5 will be equal to 2 raised to the power 8. Okay. In the same way, if we have any exponents like this in multiplication, so we can see simply here how we got this 8. Instead of doing all these things, we can simply add these power. So we can say 2 raised to the power 3 plus 5. That is 2 raised to the power 8. Okay. So this is what the first law of exponent. So we'll write it here. This is what the first law of exponent. We can make it general. This here 2 may be any number, that may be x raised to the power, here 3 may be any number, that may be suppose m. So x raised to the power m time x raised to the power n. So what it will be? See, one more condition is that the base should be same. If these bases are different, then we cannot apply these law. We cannot add this power if bases are different. Here it is 2 and here base is something 4 or 3. Then we cannot apply this law. So this power will not be added. This is the first condition to apply the laws of exponent, that base should be same. So here bases are same, x and x. Power may be different. So now we can just add these power. So it will be equivalent to x raised to the power m plus n. This is what the first law of exponents. Now let's see the second law of exponent. So second law of exponent is what if the two exponents are in division, that is division of exponents. For example, suppose if I'll take 3 raised to the power 5 divided by 3 raised to the power 2. So what I will get? So we can write this like this also in the form of fraction, like 3 raised to the power 5 divided by 3 raised to the power 2. So now what we'll write, this 3 raised to the power 5 means what? This 3 is multiplied repeatedly 5 times. So 1, 2, 3, 4 and 5. Upon this 3 raised to the power 2 means this 3 is multiplied repeatedly 2 times like this. So now what we'll do, see this 3 will cancel this 3 will cancel this 3. So 2 3's upside and 2 3's downside will get cancelled. So what is left here? These 3 3's are left here. So means finally what we'll get here? So we'll be getting 3 into 3 into 3. So that is what? How many times this 3 is multiplying here? 3 times. So we can just write 3 raised to the power 3. So means if we have something like this, 3 raised to the power 5 divided by 3 raised to the power 2. So we will be getting 3 raised to the power 3. How we got this 3? So if you'll see, instead of doing all these things, writing in the form of fraction and cancelling these 3's, then we'll get this. So instead of doing this, we can just see, if we'll subtract this power, then also we'll get this. Means like this, 3 raised to the power 5 minus 2. Okay. So then also we'll be getting that same thing, 3 raised to the power 3. So this is what the second law of exponents. So if we'll generalize this, instead of taking this 3, 5, 2, we can take general, like this may be x, anything, base may be anything, and power may be also anything, like you can take m and divided by x raised to the power n. So we can simply write x raised to the power m minus n. So this is what the second law of exponents. So let's write it here. So this will be x raised to the power m divided by x raised to the power n. So we can just subtract this power, but remember that bases should be same, then only we can apply these. So it should be x raised to the power m minus n. Okay, so this is second law of exponents. Now let's see the third law of exponent. So third law of exponent is regarding the power of power. Like suppose if we have something 5 raised to the power 2 and overall power is 3, something like this. So what it will be? So how we'll get this? So what we can write here, this power 3, this bracket has power 3, it means this whole bracket will be multiplied repeatedly 3 times. So what we can write here, first bracket, then into second time bracket, then into third time bracket. What is inside the bracket? We'll write it here. 5 raised to the power 2, 5 raised to the power 2, 5 raised to the power 2. Okay, so now if I'll write this 5 raised to the power 2 means what? 5 is multiplied repeatedly 2 times. So this will become 5 times 5, this first bracket. Into this second bracket, again this 5 will be multiplied 2 times. Then this third bracket, again 5 will be multiplied 2 times. So now see how many times this 5 is repeatedly multiplied. So 1, 2, 3, 4, 5, 6. So it is 5 raised to the power 6 because this 5 is multiplied repeatedly 6 times. So means this 5 raised to the power 2 overall power 3 if it is. So what we'll get? We'll get 5 raised to the power 6. So again, instead of doing all these things, what we can relate here. So see, if this power will be multiplied, then we'll get this. Means that will be equal to 5 raised to the power 2 times 3. So we'll be getting 5 raised to the power 6. So this is what the third law of exponents. So if it is power of power, then power will be multiplied. So in general form, we can write like this: x raised to the power m and overall power n it is. Then we can simply write x raised to the power m times n. This power will be multiplied. So this is our third law of exponents. Let's write it here. That is x raised to the power m and raised to the power n is equal to, okay. Now let's see the fourth law of exponents. So fourth law of exponents is, if something is raised to the power 0, like suppose 5 raised to the power 0, so what it will be? How we can find out? So it will be equal to 1. But how it will be equal to 1? How we can show that this will be equal to 1? This is very important. Most of the people, they don't know how we can show 5 raised to the power 0 is equal to 1, or any number raised to the power 0 is equal to 1, like x raised to the power 0 is equal to 1. How we can show it? Trust me that most of the people, they don't know how to show x raised to the power 0 is equal to 1. It's very simple. We will use this law to show how something raised to the power 0 is 1. Okay. So let's see it. If we have something like this, 5 raised to the power 0, how we can write? We can write just 5 raised to the power 2 minus 2. If it is 5 raised to the power 0 is what? 5 raised to the power 2 minus 2. So 5 raised to the power 2 minus 2 is what? It is subtraction of power. You can see this reverse use of second law of exponents. So we can write it like this: 5 raised to the power 2 divided by 5 raised to the power 2. So we can say that this will be 5 raised to the power 2 divided by 5 raised to the power 2. That is same thing in numerator and denominator. So it will get cancelled. So we'll get 1. This is how we can show that any number raised to the power, anything raised to the power 0, it will be 1. So we can take general value also, like x raised to the power 0 is equal to x raised to the power m minus m. So m minus m, it will be 0. So we can write it like this: x raised to the power m divided by x raised to the power m. So in numerator and denominator, same thing. So it will be 1. So this is fourth law of exponent. So let's write it here. So it will be like any number, anything x raised to the power 0 will be equal to 1. Now the fifth law of exponent is, if any number has negative power, like this 3 raised to the power minus 2. So what it will be? How we can write this? So it can be written as a 1 upon 3 raised to the power 2. So it will go in denominator if it is having negative power. But how it is? Let's see again how we can show this will be equal to this. So again we can say like this, 3 raised to the power minus 2 is equal to 3 raised to the power 0 minus 2, and that is equal to 3 raised to the power 0 divided by 3 raised to the power 2. So or we can say like this, 3 raised to the power 0 divided by 3 raised to the power 2, and any number raised to the power 0 is 1, so therefore 3 raised to the power 0 will be also 1 divided by 3 raised to the power 2. So see, this 3 raised to the power minus 2 is equivalent to 1 upon 3 raised to the power 2. So if any number has negative power, so it can be written in the form of reciprocal, like 1 upon 3 raised to the power 2. So this is our fifth law of exponents, that x raised to the power minus m will be equal to 1 upon x raised to the power m. This is fifth law of exponent. Now next is, what if we have power in the form of fraction? So like if we have 2 raised to the power 3 upon 2, something like this. So what does it mean? It means it can be written like this, 2 raised to the power either 3 and then power 1 by 2, or we can write it 2 raised to the power 1 by 2 and overall power 3. So we can write it like this, these both are same. And what does mean if something has power like 2 raised to the power 1 by 2, something like this, or if we have suppose 4 raised to the power 1 by 2, what does it mean? So it means that is the root of this is the second root, that is the square root. This is what the square root, or 1 by 3 power like this, 2 raised to the power 1 by 3, something like this if it is. So we have one specific symbol for this fractional power, that is called square root and cube root. So instead of writing like this, we write like this, cube root of 2. 1 upon 3 power means it is the cube root. If something is 2 raised to the power 1 by 2, it means this is the what? The square root. So we write just like this. Okay. So if I want to show this, how this, what will be the value of 4 raised to the power 1 by 2? So this is 4, so 4 can be written as 2 raised to the power 2, 2 times 2 is 4, and overall power is 1 by 2. So now if I'll apply this law, third law of exponent back here, so what we'll be getting here, 2 raised to the power 2 times 1 by 2. So this 2 and 2 will get cancelled. It means it will be 2 raised to the power 1. So generally we don't write 1, so it is just 1, 2 only. So see, 4 raised to the power 1 by 2 is 2. So we can write like this also, either 4 raised to the power 1 by 2 is equal to 2, or 1 by 2 means that is square root. So we can write the square root of 4 is 2. So sixth law of exponent, if something is like this, x raised to the power 1 upon m, so we can write it like this. Okay, if something is like this, 2 raised to the power 3 upon 2. So what I said, it can be written like this, either 2 raised to the power 1 by 2 and overall power 3, or it can be written 2 raised to the power 3 and overall power 1 by 2. So in the same way, if we have something in general value like x raised to the power m upon n, so how we can write it? We can write it like this, x raised to the power 1 upon n and overall power m, or we can write x raised to the power m and overall power 1 upon m. So in another way we can write the same thing like this, that nth root of m, nth root of x raised to the power m or we can write the same thing here, that the x raised to the power m and its nth root, like this. So that we can say here the sixth law of exponents, that is, if something is x raised to the power m upon n, so it can be written either the nth root of x and its power is m, or we can write like this, the x raised to the power m and its nth root, like this. Another law of exponent is if we have different bases. See, till now what we use here, all the laws of exponents were valid for the same bases. Now if bases are different but power is same, that we can say eighth law of exponent. So like this, something 2 raised to the power 3 into 5 raised to the power 3. So what it will be? So in that case, we can just take this power as a common. So we can say 2 into 5 raised to the power 3. So it will become something like this. 5 times 2 is 10. 10 raised to the power 3 is 1000. So we are getting here 1000. The same way here, if we'll see 2 raised to the power 3 is what? 2 times 2 times 2. 3 times repeatedly multiplied into this 5 raised to the power 3 means what? 5 times 5 times 5. So if we'll solve this, so you will be getting the same thing. This 2 and this 5 will be multiplied, it will become 10. And this 2 and this 5 will be multiplied, it will become 10. And this 2 and this 5 will be multiplied and it will become 10. So finally 10 into 10 into 10, so it will be 1000. So we can write this is our eighth law of exponents. So if bases are different, like a raised to the power m into b raised to the power m, so we can just take this power as a common. So a times b raised to the power m. So these are what the different laws of exponents. Okay student, I hope you understood. So in next video we will see the applications of the laws of exponents. We will take some examples, some problems, and then we'll solve, and then you understand better. Okay. Thank you everyone. Please like, subscribe and share this video with your friends. You are always welcome to ask your doubts in the comment section.